Okay, so today we're in section 1.3, solving equations with variables on both sides. All right, so here's your first problem. 15 minus 2x equals negative 7x. 15 minus 2x equals negative 7x. All right, so what do you notice, guys? What do you notice? Yeah, there's two variables and they're on either side of the equal sign, okay? So my goal, whenever I see this, my goal is to get the variables on one side of the equation. Now, here's the good news about it. You really can move either one. It doesn't matter as long as your goal is get my variables on one side, get everything else on the other side. You're going to get the right answer. However, in this equation, what would happen if I added 7x and that canceled and then I added 7x over here? What happens to the right side? Is there anything left? No. So basically I'm moving everything over to the left side and there's nothing left. So while that's not necessarily wrong, it creates more work. What if I added 2x? If I added 2x to both sides, that's kind of nice because now I have my numbers on one side and my variables on the other side. And that's really what my goal is, all right? So I'm not going to tell you, there is no set, you have to move all the variables on the left to the right side. There's no set rule that tells us which way we're supposed to move it. All our rule says is, I need to get my variables on the same side of the equation. Are you following what I'm saying? Just get them on the same side. So in this case, I moved my 2x because my number, 15, ends up being on one side by itself. What's negative 7 plus 2? Do you agree with Mason? Yes. Negative 7 plus 2 is negative 5x. And how would I solve for x? Divide both sides by negative 5. And x equals?
Negative 3.
Negative 3. All right, so variables on both sides, I just need to get them on the same side. Does it matter which one I move? Not necessarily, but if I know that I can move one, and then, you know, my number's on one side and my variable's on the other, well, that makes sense. That would make sense to do that. All right, let's look at this second one. Go ahead and write down that equation. 2.5y plus 6 equals 4.5y minus 1. Okay, so now, guys, when we're looking at this, okay, we could either subtract the 2.5 to the right side, or we could subtract the 4.5 to the left side. All right? And here's some of my thought process. Well, if I subtract 4.5 to the left side, what's going to happen if I subtract 4.5 from 2.5? Negative. It's going to be a negative. Do I love dealing with negatives? Not necessarily. So if I can avoid it, I will. All right, so one of the rules that I go by is I like to subtract the smaller of the two. I like to move the smaller of the two variables so I don't have a negative. All right, does it matter? No, it doesn't matter which one you move. As long as you do the steps, you're still going to get the right answer. All right, so I moved 2.5. How would I move 2.5 to the other side?
Divide by 2.5.
Not divide, because I'm moving the whole term. I would subtract it. Okay, here's why I'm subtracting, because I'm moving the whole term, and 2.5 is positive. All right, so subtract 2.5y. I will be dividing here in a minute, but not yet. So that equals 6 equals 2y minus 1. All right, and now I'm back to a two-step equation. So that first step is what we're teaching you. That's what is new for this, for these concepts, is when I have a variable on both sides, I have to move my variable. How do I do that? I add and subtract it to the other side. So I get my variable on one side, now I solve for y. So we add 1 to both sides, and we get 7 on the left side. Oops, I wrote a 7. Okay, and you get 7 equals 2y. All right, and remember what I told you the other day. Just because your answer is a decimal doesn't mean it's wrong. In this case, your answer is a decimal. How can you check it? Could I still check? Could I plug in 3.5 for both y's in the original problem? Absolutely. And both sides should equal out. All right, so there's always that option to check. Okay, example 2. What does example 2 say? What does the title of example 2 say? Distributive property. How many of you guys would say distributive property is kind of like a challenge to me? I don't quite get it. Anybody? Okay, so that's okay. All right, distributive property is somewhat new. You learned it last year, but not necessarily this difficult. All right, so what I'm hoping is that we keep getting better at distributive property. All right, so when we're practicing these concepts, that you're just, you keep getting better. All right, so write down the first one. 6 parentheses 4 minus z equals 2z. Go ahead and write that down. If you have an idea of how to distribute, go ahead and do that. Yeah, what's 6 times 4? 24. And what's 6 times negative z? Negative 6z equals 2z. Now I want you to decide, would I add the 6z to the right side or would I subtract 2z, okay? Don't say it out loud. Go ahead and do it on your paper and then solve for z. What are we going to move? The 6z, guys, yeah. Because now my numbers are on one side, my variables are on the other side, and my variable's not negative. So it's like a double win. Z equals 3. If you say 3 equals z, perfect. Okay, either way. All right, write down the next one. Write down the next problem. Negative 2 times x minus 5 equals 6 times 2 minus 0.5x. All right, so we have to remember our rules for multiplying negatives. Even number of negatives is a positive answer. So if I multiply 2 negatives, my answer is positive. If I multiply 1 negative, that's odd, my answer is negative. So my even-odd rule, that's very important when we're distributing. What's negative 2 times x? Negative 2x. What's negative 2? Guys, this is not minus. Okay, this is multiplication. What's negative 2 times negative 5?
10.
Positive 10. That's why I have a plus sign there. Okay, that's where the plus sign comes from. Because when I multiply them, the result is positive. Do you see that? If the result was negative, what sign would I put there in front of 10? A subtraction sign. It's the same thing. It's the same thing. That's why I'm trying to get my other honors class to kind of wrap their head around. They're in 7th grade. You guys remember 7th grade and kind of your concept of integers? All right, we've got to understand a positive and addition, those are the same thing. A negative and subtraction, those are the same operations. All right, equals, can I distribute this? Yeah, of course. 6 times 2? 12. 6 times negative 0.5? Negative 3x. And now I have to decide, do I move my 3x to the left side or do I move my 2x to the right side? All right. Is there a wrong way to do it? No. You could do either way. But here's my advice to you. I would choose the lesser value. Why? If you add 3x, guys, if you add 3x to both sides, now this is going to be positive. It'll be positive. If you only added 2x to negative 3x, now your x is going to be negative. Which, I mean, you can still solve it that way, but you have to deal with a negative. So we're adding 3x to the left side, and now we get just 1x, or just x, plus 10 equals 12. Now what could I do to both sides to solve? Subtract 10 from both sides. And x equals 2. And going back to what I just said, if you were to have added 2x to this side, you would have got the same answer. You would have got the same answer. You just would have had negatives. The answer is 2.